find the wavelength of the emitted radiation, and on calculation this is 65 Hertz. So resonant frequency from the central fringe is 1.8 millimeter, 20 centimeter, which is 20 into 2. With this calculation of energy, how will I find out the wavelength? Very simple. Hello students, this is SD Sir from the Temple of Excellence, Vidhyaashram, Pre-University, Mysuru. In my today's session, I will be further working on numericals on the next model question paper. The first problem, students. 2 charges plus 3 nanocoulomb and minus 3 nanocoulomb are placed 20 centimeter apart. So there are 2 charges whose magnitude is plus 3 nanocoulomb and minus 3 nanocoulomb. And the distance of separation between them is 20 centimeter. We will have to calculate the dipole moment. So first, the dipole moment has to be calculated, and the electric field due to this dipole at a point on the axis at a distance 0.04 meter from the midpoint of the dipole. So to begin with, I will calculate the dipole moment. So in accordance to whatever we have studied in our concept class, first we will calculate the dipole moment. So magnitude of the charge consider martini. Nanocoulomb ide. So Q is 3 into 10 power minus 9 coulomb magnitude, and distance of separation is 20 centimeter. Nenpidya, the distance between the 2 charges, we call it 2L, 20 centimeter, which is 20 into 2, 10 minus 2 meter. Now dipole moment is defined as Q into 2L. So this is the dipole moment, which is expressed as the magnitude of one of the charges Q into distance of separation between them. Adanne 2L anta karitini. Or P equals 3 into 10 power minus 9, 2L 20 into 10 power minus 2, and on simplification, this turns out to be 6 into 10 power minus 10 Coulomb meter. See, if you just know this expression, substituting is so easy and you arrive at 2 marks. Next, I am calculating the electric field due to this dipole, where on the axis. So what is the expression for electric field on the axis of a dipole? 1 by 4 pi epsilon naught 2 pi r square minus a square, the whole square. See, all these expressions should be strong enough for you all. Equatorial line allu kandiditteve electric field na, axis allu kandiditteve. So this is 9 into 10 power 9. Dipole moment is 6 into 0.4 divided by 0.4 square minus 0.1 square, the whole square, and on simplification, this is 1.9 into 10 power 2 Newton per Coulomb. So just juggling out the expressions so easily, we have arrived at the result. The next one, students. Now the problem says, there is an inductor of 200 millihenry, capacitor 30 microfarad, and a resistor of 100 ohms connected in series with an AC source of 50 hertz. Calculate the inductive reactance and resonant frequency. Also find the current in the circuit. So before I start, as usual, I will find the data, collect the data, analyze the question. So inductor 200 millihenry, milliallide, so minus 3 Henry. Capacitor 30 microfarad, minus 6 farad. Resistor 100 ohm. They are connected across 220 volt 50 hertz AC. So VRMS is given 220 volts, frequency 50 hertz. Please note, students, this is the applied frequency, not the resonant frequency, the frequency in series with the components. So first, what do I calculate? inductive reactance. So I know inductive reactance is XL, which is 2 pi FL. Simple agi gottirlebeku. Wherever you work out problems on AC, calculation of XL and XC is becoming mandatory. So this is 2 into 3.14. Frequency was 50. Inductance ST there, 200 millihenry. So 200 into 10 power minus 3, which means this turns out to be 62.8 ohms. So very clearly, I have calculated XL. Now students, resonant frequency. Very clearly we know the expression for F0, which is 1 by 2 pi root LC, 1 by 2 into 3.14. Inductance value 200 into 10 power minus 3, 30 into 10 power minus 6. And on calculation, this is 65 hertz. So resonant frequency turns out to be 65 hertz. Now I should also know current flowing through the circuit. Impedance gottilla. Mat puna XL kandirdiddini. Again calculate XA. Again calculate impedance. But my conceptual knowledge should help me to minimize my efforts here, because I know at resonance, whenever resonance is achieved, Z is equal to R. Yavaga resonance condition, the moment you have F0 in picture, Z becomes equal to R, and therefore IRMS is VRMS. Instead of Z, it is R. So this is 220 by 100, which is equal to 2.2 ampere. So this is the current that is flowing through the circuit. The next one, students, our famous Young's double slit experiment. In Young's double slit experiment, the distance between the slits is 1.2 millimeter. And the screen is 0.5 meter from the slits. Distance between the slits kottidare 1.2 millimeter. Distance between the screen and the slit is given 0.75 meter. If the distance of the fifth bright fringe, please note, fifth bright fringe from the central fringe is 1.8 millimeter, calculate the wavelength of light used. Also calculate the distance of fifth dark fringe from the center. We will analyze. We will pick up the data. distance between the slits, small d, is 1.2 into 10 power minus 3 meter. Distance between the screen and the slit, capital D, is 0.75 meter. The fifth bright fringe from the central fringe is at a distance of 1.8 millimeter. ಅದನ್ನ x ಅಂತ ತಗೊಳ್ತೀವಿ. 1.8 into 10 power minus 3 meter. First, I will calculate the wavelength of light used. Now, bright fringe ಕೊಟ್ಟಿರೋದು fifth bright fringe. N is 5. I've also told in my concept class, when it is bright fringe, whatever number it is named, write down. Fifth bright fringe, N is 5. What is the expression for its distance from the central fringe? Xn is n lambda d divided by small d. ಏನನ್ನು ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡಕ್ಕೆ ಹೇಳಿದ್ದಾರೆ? ಲ್ಯಾಂಬ್ಡಾ. So lambda is xn into d divided by n into capital D. So this is 1.8 minus 3. Distance between the slits 1.2 into 10 power minus 3. 5 into 0.75. So on simplification, very easily, this turns out to be 576 nanometer. So, corresponding to bright fringe, wavelength was asked, I calculated. For the same fifth dark fringe, I will have to calculate its distance from the center. Therefore, for dark fringe, n is 4. Why? I told, if it is a dark fringe, you will write 1 less than the given number. So n is 4. Now, what is the formula for the dark fringe? Xn is 2n plus 1 destructive interference. And when you substitute and simplify, you get the answer as 1.6 millimeter. See, very simple. No rocket science. Know the expressions. Easily you get the answers. The next one. An electron transmission occurs from n equals 4 to n equals 2 energy levels in hydrogen atom. Find the wavelength of the emitted radiation if the electron in the ground state has energy minus 13.6 electron volt. Now the electron transition is happening from the fourth orbit to the second orbit. We know the energy of the electron is minus 13.6 n square electron volts. Fourth orbit to second orbit. So E4 minus 13.6 by 4 square, which is equal to minus 0.85 electron volt. E2 minus 13.6 by 2 square, which is minus 3.4 electron volts. So what is E? E4 minus E2 on simplification, which is 2.55 electron volts. With this calculation of energy, how will I find out the wavelength? Very simple. Again, energy of the photon, E is hc by lambda, or lambda is hc by E. So Planck's constant 6.625 into 10 power minus 34, 3 into 10 power 8, E 2.55, but since this is converted into joules, into 10 power minus 19. So this is nearly 498 nanometers. So again, I have worked out a series of problems from this model question paper. The next session, I come up with another question paper. Again, we solve problems. Come prepared. Have a nice time. Thank you.